Bom, a apresentação agora é do professor Júlio Ibarra, da Florida International University. Ele vai nos fazer uma atualização aí do andamento do programa, do projeto GENI, Global Environment for Network Innovation, que basicamente é o projeto que nos Estados Unidos está patrocinando, o programa, né, que nos Estados Unidos está patrocinando os projetos de SDN, né, de redes definidas por software. O Júlio não fala português, ele fará a apresentação em inglês, mas ele fala espanhol, então ele pode entender perguntas que forem feitas em português, se não falar muito rápido nem muito enrolado, e de qualquer modo, ele fala um inglês muito claro, então creio que todo mundo compreenderá tranquilamente. So, Julio, we'll welcome you, please, and start.
Thank you very much, Professor Lopez. It's a pleasure to be here this morning to present to you on, thank you, the GENI project and give you an update of what is happening in future internet development in the United States. So the title of my talk is Update on the Global Environment for Network Innovations, which is what GENI stands for. And as my first slide shows, I'm from Florida International University in Miami. We've been working with ANSPI for almost 10 years since we established our first connections to Brazil back in 2002, 2003. And I've been collaborating with Professor Lopez for a number of years now, and our projects continue to evolve, and I'll tell you a little bit about that in my slides here. I'm also the Assistant Vice President for the Center for Internet Augmented Research and Assessment at FIU, and we do a lot of work for the National Science Foundation. A lot of our funding for these projects comes from the NSF and from the different networks that connect at our facility in Miami to connect to networks like Internet 2, ESNet, National Lambda Rail, and other international networks. So let me get started with, okay, here is the outline to my talk. I'm going to talk a lot about the GENI project, give you an introduction and an update, then about the project that we have with Brazil called America's Light Path, and how we're enabling international peering with Brazil for projects like GENI, and then a little bit about the applications that are using GENI. So first, let me introduce GENI to you. One of the challenges that computer scientists and network researchers have is being able to conduct experiments at scale. And this has been a problem for some time. You have issues that you can't really understand or predict behavior of complex large-scale networks when you're just confined to working in a laboratory. Or if you're dealing with new technologies towards driving innovation, you have issues where you'll have barriers in working with experimentation unless you're able to work at scale to test new architectures and services and new technologies, as well as addressing issues in society such as what's happening with the internet, with security, or being able to address different kinds of problems that are serving different social interests. Unless you have an environment in which you can test these new technologies, it becomes very, very challenging. So GENI is about creating an infrastructure to allow researchers to conduct these experiments, measure, and be able to come out with new technologies, new innovations to improve the internet of the future. So what is GENI? GENI has evolved as a nationwide suite of infrastructure for at-scale experiments in networking, distributed systems, security, and novel applications. The key concept here is at scale, and I'm going to talk a little bit more about that. GENI provides a huge opportunity for developing leading-edge research in next-generation internets and also to provide mechanisms for rapid innovation for novel large-scale applications. The key concept GENI has started to introduce and enhance is the concept of slices and deep programmability. And I'll talk a little bit more about what that means. But here you have, for example, if you look at the internet provided open innovation for the development of application programs. GENI is about open innovation deep into the network. And this is where the concept of deep programmability comes in. And I'll talk a little bit more about that as well. So if we look at what GENI means in reference to slices and deep programmability, we're looking at having the ability of giving a computer scientist or a researcher, now let me see here. For example, here you have a computer scientist, here you have another computer scientist, the ability of installing software that they want to be able to use throughout the network. And they're able to create what's called a slice that is able to exist within a virtual networking system by which to test different types of network concepts, which involves things like firewalls, routers, and clouds. And so the slice can be isolated from another slice. So if you're a researcher, you create your own slice, you're able to run your experiments in that slice, and it's not going to interfere with the slice of another researcher. Very similar to the concept of virtual machines. So one of the things that we are doing with GENI is being able to run what we call many different types of future internets, all in parallel. And I'll talk a little bit more about what they mean by that. Okay. Let me not get ahead here. Okay. So here's an interesting representation of what they mean by a slice. You take, for example, your laptop or your mobile, and you're able to, through slices, still have your connection to the regular internet. As well as, if you're a researcher, you create a slice from your laboratory to different types of devices. And with that slice, you're able to test different kinds of networks. All right? And this is the concept of being able to create these virtual environments, these slices, to allow you to test different kinds of networks within the GENI environment and be able to do this at different scales. So here, for example, GENI can grow. You have GENI running on a campus, a research laboratory, on multiple backbones. The idea is to be able to grow this in such a way that the technology is independent of the underlying infrastructure, very similar to the idea of how virtual machines have evolved as well. And I'll give an example of that later in my talk. But the idea is to avoid technology that will lock in the developments that are going on by different researchers. You allow the infrastructure to hide these details, and you're able to run different kinds of experiments in these slices that are independent of underlying protocols. All right, and this is what's evolving now, and what we're calling the GENI ecosystem. And another key point is you notice here where GENI is evolving to not only work with universities, but also with commercial organizations that have deployed clouds, as an example, also with corporations. So it's a partnership with government, private companies, with all sorts of different types of special interests. It's not just strictly academic. And this is really important to allow this to evolve and to grow very much like the internet did years ago. So here's the architecture that GENI has. GENI has, for example, this is a hierarchical architecture going from the providers, let's say an ISP. You have here research backbones, you have the metro, and then this interconnects with regional networks. So for example, this would be, let's say, ANSP or maybe RMP, and this would be a metro area that is part of their network. And then you have the campuses that are also connected to the regional networks. And so this provides a flexible infrastructure involving networking, computation. It's able also to support different types of communities such as physics, genomics, many different domain sciences. It also is consistent and supports the idea of hybrid networking. So for example, the concept of hybrid circuits using technology such as OpenFlow, and is able to work with different kinds of computational facilities such as distributed cloud racks. We now have introduced into the environment what's called GENI racks. And GENI racks provides computation, storage, instrumentation for measurements. So all of these things can be part of the ecosystem to allow researchers to be able to try new ways of creating internets. So to wrap up the introduction about GENI, I don't want to, I'm blocking your view here. Let me move here. I don't want to. So GENI, the main theme here is to support at-scale experiments, all right, which may or may not be compatible with today's internet. This is not, the compatibility with the internet today and the internet protocols is something that we don't want to have as a limitation. So it's like a clean slate. You're able to innovate how you conceive of networks and be able to test this within the GENI environment. The idea of being able to replicate networks is very important. If you create a network that has interesting results, well, another researcher may want to be able to reproduce that. So the ability to do that is very important. And also the concept of opt-in, so that you have real users. People who are using networks today should be able to use the GENI environment as a real network as well. And then the idea of having good instrumentation and measurement, this is very important because you need to collect data. You need to measure and understand how your experiment works. And so the idea of having measurements along different parts of the experiment is very important. And then the idea of also having the ability to scale, large-scale growth for successful experiments. Some of these experiments may run for a long time, and that's okay. We want you to be able to run your experiments as long as possible and not have any restrictions with the kind of research that's needed. This is part of what is important for computer scientists and network researchers, is to be able to have an environment to work for a long time as they need to. So in summary, GENI creates a huge opportunity for ambitious research. And this is part of the idea of allowing computer scientists and the researchers the ability of doing this, not only within the US, but also with collaborators worldwide, here in Brazil. Okay, I'm going to talk now a little bit about a project that is working today, which is called America's Light Paths, and how it's enabling international peering with Brazil, and how GENI ties into this as well. So here you have some of the international projects that GENI is working with. There's a number of projects with Asia and Australia, and there's some projects with Europe, and now with Brazil, we just started with the Proto-GENI environment. I'm going to talk a little bit about that, some results from the GENI conference that I attended last week. But GENI is collaborating with what we're calling peer efforts outside of the United States, and it's using the ability of a researcher-to-research collaboration to be able to share resources and create an environment that's beneficial to all researchers. And so here, this connection that you see is leveraging what we call the AmLight project resources, and I'm going to talk a little bit about that. So we started this project back in 2006, and it's actually a second phase of a project that started even earlier back in, actually no, this one started in 2010. The earlier project started in 2005. So this built upon the one from 5 previous years called Ren Lila. This one, you could see here, the key thing I want to show is these connections from Miami to Sao Paulo. is infrastructure that is being used by GENI to connect to Brazil. And in addition to, so these two connections, as described here, are two 10 gigabit circuits for a total of 20 gigabits of bandwidth. We also have a connection on the West Coast that connects San Diego to Tijuana, and it provides connections to Mexico and also Latin America. The Red Clara network has a connection through that point. And then we have what's called the AmLight Andes, which is this connection here, right now from Santiago, Chile to Miami, and another one from Mexico City to San Antonio, which is this one here. So we have a number of connection points from the United States to Latin America, but the main one that we're using is this one here for the GENI project at this time. I also want to draw your attention to a facility we have in Miami called AMPATH, which you may have heard about that. It's an international exchange point that supports connectivity between the United States, Latin America, and the Caribbean. And this is where our main path is between Brazil and the United States at this time. And then here in Sao Paulo, we have another exchange point that emerged called Southern Light. It's a distributed international exchange point in Sao Paulo, and it has the connection for AmLight East at Sao Paulo here, and has connections to ANSP, RMP, and Red Clara. This is key infrastructure for projects like GENI and the fiber project that's going on in Brazil. We're working very hard to develop this infrastructure to support technology such as OpenFlow and dynamic circuit provisioning. And so far, the work that we've done has provided some very good results with these technologies. And we're just beginning to do this. I had a very nice dinner with Professor Lopez last night, and we were coming up with new projects, new ideas to help support the researchers here in Brazil and at FIU and in the United States. So that's all I'm going to say about the AmLight project, America's Light Path. If you have any questions about that, I'll be glad to address them later. I'm now going to talk a little bit about how GENI is being used by different projects in the United States. So here are some statistics on how GENI is growing. So these show you numbers of the number of the experiments that are going on in GENI. How am I doing as far as time? Okay? No problem? 10 minutes? Okay. So here you see, for example, how GENI, the number of experiments has been growing over the years. In GEC 14, it almost reached 180 experiments using the Proto-GENI framework. I have 20 minutes, okay. Thank you. So in the United States, the growth has been very good since the GENI project started, okay? Now, if we take a look at the number of experiments, the previous slide was the number of experiments. Here is the size, growing number of experiments. I think this might be is it the same slide? Okay, this is the number of slivers, okay, which is basically if a sliver is essentially a piece of a slice that's running on a node, all right? Whereas a slice can be running across many nodes in different network domains. This is a measurement of a piece of a slice running on a particular node, is what they have here. And you can see that this has been growing over the years as they've been doing more demonstrations in the GENI conferences. All right, and so part of what the GENI community wants to do is increase this even more through international collaborations and federations with other networks. One of the projects that we have with GENI at FIU is called Primo GENI. Some of you may have heard of this project. And this is a project that develops a layer called an aggregate that runs on virtual machines, and it's for large-scale network simulation and emulation of experiments. We currently have this running at Florida International University, and it's also running at the Proto-GENI site in Utah. And we're in the process now of having it installed at ANSP. The first stages of it are in operation. This was done for the GENI conference that recently took place in Houston. So here's an architecture of that project. And part of what it does is it uses a substrate layer of computation, storage, and network resources. And then it provides a virtual environment, this meta resource layer, so that you have virtual resources upon the physical resources to run a simulator called Prime. And then the simulation and emulation layer is a layer that maps simulator instances on these hosts, and then establishes these inter-VM communication channels between the different emulated hosts to create real-time simulator instances. And so with this program here, or this system, you have then connectivity to other slivers on different slices through this emulation gateway that you see here. And then from here, researchers are able to create slices to be able to run these simulation programs and emulation programs. And the idea is to allow researchers interested in running real-time, large-scale emulation and simulation to do this on a slice. This will be available very soon. We hope to have this working in the ANSP facility to connect to Proto-GENI within the coming weeks. And if you'd like more information, you can go to this site here that gives you a lot of documentation and design information for this project. Another project that we have, a recent award at FIU, is the CCNIE program, which means the Campus Cyber Infrastructure, Network Infrastructure Engineering Program. And I think there was a presentation yesterday, your presentation, that mentioned this program. This is an investment the National Science Foundation is doing to enhance infrastructure on campuses. And part of it is to, well, in our proposal, we're going to be using OpenFlow to make the improvements on the campus to enhance the ability of science projects to use the network. And part of what is going to be done is to create a science DMZ. And this was mentioned yesterday. The idea of a science DMZ is to create an environment that allows for different types of network flows to exist along with the production infrastructure. So we were going to be using OpenFlow to create this, and it's going to leverage resources on AMPath and AMLite to support these end-to-end science flows. And part of what we propose is to extend this capability to Brazil, to work with the different OpenFlow projects here. We have support from ANSP and RMP, and we're also going to be extending this capability to Chile to connect to the astronomy sites there, and be able to run some of these flows through the science DMZ from FIU all the way to Chile, and as well as provide connectivity to other sites in the United States. This link here, if you're interested, provides you a list of all of the awards that were made to this program. There's a lot of different kinds of projects that may be of interest that you may want to collaborate with universities. Once this infrastructure is in place, it's available to use with all of these universities, as well as to leverage the capabilities of the new Internet 2 100 gigabit network that we will be we will be using as part of this project. And this is what was demonstrated. This is the test that was demonstrated last week at the GENI conference. This is showing here a representation of the proto-GENI environment, the nodes at USP and ANSP, and this was demonstrated at this GEC conference. And what it did was create a slice from Tokyo. They have a technology over there called vNode, which is not the same as proto-GENI, but they use some kind of a gateway technology to interconnect vNode with proto-GENI. They're in Utah, and then we had the connection. A dynamic circuit was established from Sao Paulo to Utah through Miami to connect the cluster at USP at LARC, and that is what we have represented here. And so this worked very well. We were able to, with the work of Fernando and other people, and also at like Georgie Marcos and Carlos at ANSP, very quickly able to connect all of these together using the network infrastructure and do this experiment there. And you can see here, this is the actual screen at the demonstration showing these nodes. And as I've been explaining, and the results were very exciting at the GENI conference. Everybody there is very excited about doing more collaboration with Brazil now that we have these resources online. And so I think the idea is to build upon this for further future internet experiments between the United States and Brazil, and to start seeing how we can collaborate for the future GENI conference. I believe will be in March of next year. If you're interested, there have been some publications about GENI in these journals. Here are some of the citations. And these are just a variety of different projects that are using the GENI infrastructure for experimentation. There is also a tutorial and summer camp programs that are available. There was one that took place in 2012 at GEC 13 in Los Angeles. Rochester Institute of Technology held one in May. And there's going to be a new one at the University of Connecticut in June of 2013. This is the contact information. I think that they're open to have participation from faculty and students from different countries. So if this is of interest, please feel free to contact them. They can tell you more about what the requirements are, or if you have any questions, I can help as well, put you in contact with the people who are doing this. But this is a good opportunity to go to like a summer camp and actually work with GENI, do some experimentations using these tools. And I will stop here. Thank you very much.
Thank you, Julio. Thank you very much. We still have time for some questions, perguntas.
Sure.
Maybe I missed this information, but how many, until now, I understand that the GENI is a continuous project, but until now, how many money, how many time is spent to achieve the initial goals of this project?
How much money?
And how many time?
How long? Okay, yes. I think, well, we just finished GEC 15. And it's been about a 5 or 6 year project because they hold 3 conferences per year. So GEC 15, it's about 5 or 6 years it's been in duration. The funding for GENI, I must say that it's been minimal. But I would say that the success of GENI has been the leveraging that GENI does. And what do I mean by leveraging? GENI takes advantage of other investments that the NSF has made. So like, for example, the America's Light Path project. This is an investment the NSF has made through a different program. So GENI uses that infrastructure for collaboration with Brazil, for example. So GENI doesn't get any money for building networks. They basically use investments that are part of other projects to do that. So what GENI has been funded to do is more for developing software, such as Proto-GENI, for example. They have funded computer scientists to do that development work and to get that deployed on infrastructure. Most of the technology that GENI has invested in is off-the-shelf kinds of systems, very inexpensive Linux or VM type of technology. And so I don't have an exact number of what the investment so far has been. I can get it if that's of interest to you, but it's in comparison to other investments, like for example a telescope, GENI is very small, very small in comparison.
Eu poderia te dizer uma coisa sobre essa metodologia da NSF. Isso é uma coisa que nós nunca tivemos aqui no Brasil, por parte do CNPq ou da FAPESP. Eles têm feito, nestas áreas, como TI, eles têm feito muito esse tipo de projeto. Eles têm vários projetos regulares que eles financiam regularmente. Por exemplo, os projetos de infraestrutura de rede, projetos de pesquisa em hardware, projetos de pesquisa em áreas de software. E aí eles fazem um projeto como o GENI, em que o orçamento específico para o projeto é bastante pequeno, mas os outros projetos eles são aprovados com a condição de dar suporte a este projeto, que vamos dizer que usa todos os outros. Então, na verdade, o financiamento direto é pequeno, mas existe um financiamento indireto muito grande. Então, por exemplo, vocês viram ontem, na apresentação do Marcelo Molinari, ali, aquela rede monstruosa nacional que tem nos Estados Unidos, OpenFlow em 100 GB, que a NSF montou e que a Brocade aí ganhou uma parte dos nós. Então, esta rede ela é a contribuição da Internet 2 com fundos da NSF para o projeto GENI. Então, embora o projeto GENI não receba isto, tem alguns milhões de dólares ali que chegam indiretamente. Tá? Então, a metodologia de investimento é diferente. Mais perguntas? Okay. So, Julio, thank you very much. Thank you for your coming here and your beautiful presentation.